Hi, welcome to Math with Beth, and we are going to look at parallel and perpendicular lines and the point slope equation. So, parallel lines are two lines that never hit each other, but something special about them that helps when you're dealing with some of these word problems is that they always have the same slope. Because if this line's going up and over at a certain amount, this one would have to be doing the exact same thing for them to never hit each other. So that is something special about parallel lines. For perpendicular lines, they do hit each other, so they don't have the same slope, but perpendicular lines are special that when they hit each other, they are making these right angles. So every angle here is 90 degrees. So something special about their slopes that makes this one certain thing happen is that their slopes are opposite, which means if one's positive, the other one's negative, and they are reciprocal. So just to make sure you understand, some examples of slopes for perpendicular lines would be, if the first one was 2/3, the other line would have to be negative, and this is just the slope we're talking about, -3/2. So that is the opposite and the reciprocal. If one slope was -4, then the other slope would have to be positive, and the reciprocal of 4 is 1/4. So here are just some examples of the types of slopes we're looking for perpendicular lines. So now for this new formula, point slope. A lot of you are familiar probably with y equals mx plus b. That is the slope-intercept form of a line, where this is the slope and this is the y-intercept. But this is another equation that is helpful if you don't have the y-intercept, if you just have a random point. So this is the one we're going to be practicing today. So first example, find the equation with slope 2. So we have our m and point -2, 1. This could be the y-intercept, but only if the x value was 0. So if it's not a 0 here, this is a random point, and we're going to call it x1, y1, so we can use this new formula. So plugging things in, the y and the x are going to stay. Everything else is what we have here. So y minus y1, which is 1 in our problem, equals the slope 2 times x minus x1, which is -2. So now it depends on if they want us to keep it in this form or if they want us to change it to slope-intercept form. So if they don't specify, this form is totally fine. This is an equation of a line. I would just probably make the minus -2 turn into plus. So this could be your final answer. If they did say give the equation in slope-intercept form, you could still do everything we just did. Just at the end, you would distribute the 2 and move this one over. So make sure you know what form they need the answer, because if they don't specify, you can stop right here. For the next two problems, you need to remember that we have some special types of lines, horizontal lines, which are always in the form y equals a number, and vertical lines that are always in the form x equals a number. So just a little reminder about those two special lines, because this problem says, find the equation of the horizontal line. So we already know it's going to be y equals a number that contains the point -5, 2. So we don't need to do all of this work like we did before, because we automatically know horizontal lines are special lines that are just y equals a number. So if it has to go through this point, this is all we really care about. That is our final answer. So the special line should be the easiest ones if you can keep straight which is which. And then this is also about a special line. Find the line parallel to x equals 5. Well, if x equals 5 is a vertical line, the only thing parallel to it would be another vertical line, which means we know our answer is going to be x equals a number. So that takes care of the parallel part. But now if we want it to contain this point, it has to be that x. So these were just two examples of when you don't need to use all these fancy formulas. Next example, find the slope and y-intercept of this line. Again, we don't need any fancy formulas because we will know the slope and the y-intercept if we move stuff around and get it into this form. So I'm going to subtract my x. You can write 15 minus x, or you could write negative x plus 15. Either way is fine, but you just can't combine those and make it like 14x. That does not work. And now I'm going to divide everything by 3 and reduce. So y equals negative x over 3 is fine, but if we're going to graph this at some point, this might be the way you'd want to write that, because that is the same thing as negative x over 3 plus 15 over 3, I can definitely reduce. So now if they want to know the slope and the y-intercept, my slope is negative 1/3. My y-intercept, or the b, is 5. Okay, let's get back to our new equation. Find the equation parallel to this line that goes through this line. So this is not a y-intercept, so they just gave me a random point, so I'll call it x1 and y1. And now I wish they gave me my slope, but they did in just a more complicated way. By saying that we want to be parallel to this line, they are telling me, please use the same slope. So we now have our slope and our random point. So we're going to use this new equation, the point slope formula, to plug in what we know. So y minus 4 equals our slope, which is negative 1/2, x minus the x, which is negative 8. They did not tell me what form to give them my answer, so I'm going to leave it in this form, but I'll go ahead and change that minus minus to a plus. Done. Next problem is the exact same, except for instead of parallel, we want to be perpendicular. So we need to take a second to remember what that means. So again, if I want to be perpendicular to this line, they're telling me something about the slope. But what they're telling me is that I don't want to use the one that's here, but I want to use the opposite, so positive, and the reciprocal, so flip, which means instead of negative 1/3, I'm going to use a slope of 3. And I want to go through this point, so they've given me another random x and y. So I'm going to use that same new formula. Y minus the y equals my slope, x minus the x. I'm going to go ahead and change the minus and negative to a plus, and I'm done. Just so you've seen it, if they did want the answer in slope intercept form, I would do everything I just did, but then I would go ahead and distribute the 3. So 3x plus 6, and then move this minus 4 to get it in the form they asked for. So no matter what form they want the final answer in, if I have a slope and a random point, I'm usually going to start with this form, the point slope form. On any of these, reach out.